The outer solar system is not empty. That much scientists now agree on. Something is out there, beyond Neptune, beyond the scattered debris fields, beyond everything we have mapped and named. Something with enough mass to bend the orbits of distant worlds. Something that has been hiding in the dark for longer than human civilization has existed. They call it Planet 9. But here's what no one is asking out loud. What if it isn't just a planet? Start with what you know. The solar system has 8 planets. That's the official count, the version taught in schools, printed in textbooks, recited by children who have memorized the order since they were small. 8 planets, clean, certain, complete. Except it isn't. In 2016, astronomers Konstantin Batygin and Mike Brown published a paper that quietly unsettled everything. They had been studying a cluster of distant objects, trans-Neptunian objects, frozen bodies tumbling through the outermost reaches of the solar system. And these objects were behaving strangely. Their orbits were clustered, aligned, tilted in the same direction, as if something massive had herded them into formation. The probability of this happening by chance, less than 0.007%. Something is out there. The math points to a planet roughly 10 times the mass of Earth, orbiting the Sun at a distance, somewhere between 400 and 800 astronomical units. At its farthest point, it may reach 1,000 to 100 astronomical units, so distant that sunlight, traveling at 300,000 kilometers per second, would take more than 16 hours just to arrive. We have not seen it. Every telescope we have pointed in its estimated direction has returned nothing. But the orbits don't lie. Let's be precise about this. Planet 9, if it exists, sits in permanent darkness. The Sun, from that distance, appears as nothing more than a bright star. There is no warmth, no solar wind to speak of. Temperatures on its surface would hover near absolute zero. It is, by every measure, one of the most hostile environments imaginable. That is the assumption. Here's what that actually means. Hostile by human standards is not the same as hostile by all standards. Life on Earth spent its first billion years as single-celled organisms, surviving in boiling, hydrothermal vents, in acidic pools, in environments that would kill a human in seconds. We call these organisms extremophiles. They didn't evolve despite the hostility. They evolved because of it. The coldest, darkest, most isolated corner of the solar system is not automatically a dead corner. And Planet 9 has something that changes the equation entirely. Size. A planet 10 times Earth's mass generates substantial internal heat. Heat from radioactive decay, from gravitational compression, from the slow settling of a world still cooling from its formation. That internal heat persists for billions of years. It doesn't need the sun. It carries its own warmth. Beneath the frozen surface, if one exists, there may be liquid water. Not might, may. The physics permits it. And then something happened. Something that reframes every assumption we've been making about this hidden world. In 2019, researchers modeling subsurface oceans on distant icy bodies found that the conditions for liquid water beneath an ice shell are far more common than previously believed. Europa has it, Enceladus has it, and actively vents it into space. Ganymede, Titan, Pluto, liquid water, in some form, persists in the outer solar system with remarkable consistency. Planet 9 is larger than all of them. If a world the size of Neptune's smaller cousins can sustain internal heat long enough to maintain liquid beneath its surface, then Planet 9, with 10 times Earth's mass, has been doing the same thing for potentially 4 billion years. 4 billion years. Let that land. Earth produced complex multicellular life in roughly 600 million years. Intelligence, in the crude, tool-using sense, took another 540 million after that. The timeline from ocean chemistry to language and civilization fits inside a window of roughly 1 billion years. Planet 9 has had 4 times that window. In the dark, in the cold, out where the sun is just a star. But here's the problem. We're building a case on inference, on orbital mechanics, and thermal modeling, and the extrapolation of biology we understand only from a single data point, us. Every assumption in this chain is reasonable. None of it is evidence. And yet, The search for extraterrestrial life has always operated on one foundational principle: follow the water. That principle led us to Europa, to Enceladus, to Mars. It has guided billions of dollars of mission funding and decades of scientific careers. We follow the water because water is, as far as we know, the one non-negotiable prerequisite for life as we understand it. Planet 9, if it has subsurface oceans, has water. More than that, it has stability. The outer solar system is not chaotic. Planet 9's orbit, however elliptical, is consistent. It has not been disrupted. It has not been bombarded into silence. Whatever exists on or beneath its surface has had the same quiet, dark, frozen consistency for billions of years. Stability is the second prerequisite for complex life. Time, water, stability. Planet 9 may have all three. Here's where it gets strange. If a civilization exists, or existed, on a world in the permanent outer dark, their entire conception of the universe would be different from ours. They would have no sun to worship, no seasons, no visible stars during what passes for daytime because there is no daytime. Their sky, if they could reach a surface, would be a permanent field of stars with one slightly brighter point that is their host star, 800 away. They would have developed in isolation so complete that the word isolation doesn't capture it. We talk about the loneliness of space. We feel it abstractly, the sense that Earth is small and the distances are vast. But we have the sun. We have a warm nearby star whose gravity defines our existence, whose light feeds our food chains, whose cycles organize our years. An intelligence born in the dark would have none of that. Their physics would be the same as ours. The constants don't change, but their cosmology, the story they told themselves about their place in the universe, would have started from a fundamentally different premise. Not warmth and light, cold and silence. Let's be precise about this. There is a concept in astrobiology called the rare Earth hypothesis. It argues that the conditions which produced complex life on Earth were so specific, so unlikely, so dependent on the particular arrangement of our solar system, our sun, our moon, our magnetic field, and our position in the galaxy, that intelligent life is probably extraordinarily rare. Planet 9 breaks most of those assumptions. It has no large moon to stabilize its axial tilt. It has no magnetic field we know of. It has no star close enough to matter in any biological sense. It sits in a region of space so remote that even the cosmic ray environment is different, quieter, in some ways, than what Earth experiences. And yet the thermal energy is there. The water may be there. The time is certainly there. The rare Earth hypothesis assumes life needs what we have. Planet 9 suggests the list of what life needs may be shorter than we thought. Much shorter. And then something happened that should be part of every conversation about Planet 9. And almost never is. We don't know where it came from. The leading hypothesis is that Planet 9 was formed in the inner solar system, in the same region where Earth and the other rocky planets were built, and was subsequently ejected outward by gravitational interactions with Jupiter or Saturn. In the early chaotic period of the solar system's formation, it was thrown out, exiled, sent to the dark. This is called the ejection hypothesis, and it has a quiet implication that most papers don't linger on. If Planet 9 formed in the inner solar system, in the region where warmth and chemistry and complex molecular interactions were possible, then it spent its earliest period of existence in conditions not entirely unlike those that produced life on Earth, before it was thrown out, before the long cold began. Whatever chemistry started in those early warm conditions did not necessarily stop when the planet was ejected. It slowed, it changed. But chemistry doesn't simply halt because the environment changes. It adapts, it finds new pathways. It reorganizes around whatever energy source remains. 4 billion years is enough time for a great deal of reorganization. We have sent probes to the outer solar system. Voyager 1 and 2, Pioneer 10 and 11, New Horizons. Each one launched decades ago on trajectories that were plotted before Planet 9 was even hypothesized. None of them are aimed anywhere near its estimated position. The fastest human-made object ever launched is traveling at roughly 61,000 kilometers per hour. Planet 9, at its nearest estimated point, is approximately 3.7 trillion kilometers away. At that speed, it would take our fastest probe roughly 6,900 years to arrive. We are not going there, not soon, not in any time frame that a living human can personally anticipate. So we are left with the orbital signatures, the mathematical ghost, the invisible hand that is bending the paths of distant ice worlds and leaving its fingerprints in geometry. We know something is there. We know almost nothing else. There is a broader question underneath all of this, one that the Planet 9 hypothesis surfaces without meaning to. We have been searching for extraterrestrial intelligence by pointing our telescopes outward, toward other stars, other galaxies, the vast external universe. We scan radio frequencies. We look for laser signals. We model the atmospheres of exoplanets thousands of light years away. And in our own solar system, close enough that the sun's gravity still holds it, there may be a world that has had for billion years to develop whatever it was going to develop. We don't know what's there. We can't see it. We haven't tried to reach it. And in the silence of that ignorance, the orbital math just keeps pointing at the dark, patient, precise, certain that something is there, completely indifferent to what it might be. The solar system is not empty. We just haven't looked at all of it yet.